In this video, I'm going to talk about electric flux and electric flux density. I will start explain electric flux, then I will relate electric flux with electric flux density. Force acting on a charge will move along certain path. This path is known as line of force or a flux line. Here we have three charges with the magnitude of 2, 6 and 8. Here the first charge has 2 lines, the second charge has 6 lines, and the third charge has 8 lines. These lines or the field lines represent the electric flux. Thus, we can write the equation as this. The electric flux due to charge is equal to the magnitude of the charge in coulombs. And this is scalar because it's only lines. In previous slide, I showed electric flux coming out from an isolated positive charge. Now, take a look at these two different charges. As we can see here, the positive charge repels the charge. That's why the electric flux are outwards, while the negative charge pull in the charge. Thus, it is in inward direction. If we have two same charges here, they will repel each other. So, as conclusion, we can say like charges repels and opposite charges attract. Another important information that you need to know is the electric field at any point is tangential to the line of the electric flux. Electric flux density is the total flux passing through a defined area that is perpendicular to the direction of the flux. Thus, the relationship between flux line and electric flux density is given by this equation, where the S is the differential surface area element. It is vector perpendicular to the surface. From this, we can write the electric flux as the integration of electric flux density and differential surface element. The flux passing through S is the maximum if electric flux density and differential surface element are in the same direction. Early investigators established properties of electric flux, which are it must be independent of the medium. Its magnitude solely depends upon the charge from which it originates. If a point charge is enclosed in an imaginary sphere of radius r, the electric flux must pass perpendicular and uniformly through the surface of the sphere. And the last one is the electric flux density. The flux per unit area is then inversely proportional to r squared. Recall that electric field intensity also satisfies the property except its magnitude depends upon the permittivity of the medium. Thus, electric flux density, D, can be defined in terms of electric field intensity using this equation. So, we can write the electric flux as this equation as well. So, that's all for this video. Thank you.